Hello and welcome to the introduction video of mBFR. In this video, we present a real plant case study using mBFR technology. Let's begin. Toray has developed the original innovative water quality evaluation indicator for RO feed water, membrane biofilm formation rate, mBFR. mBFR can predict concerns and risks of biofouling in advance, and it can also contribute to quickly identify the cause and resolve issues when fouling problems occur. The measurement method is quite simple. Simply connect the mBFR measuring column kit to the sampling point of the plant and let the target water flow vertically from bottom to top at a constant flow rate. No special construction work or shutdown is required. mBFR is defined as the rate of ATP accumulation per day. Firstly, original separable columns that simulate RO membrane surfaces are prepared, and ATP attached to the RO membrane piece inside the column is periodically measured. As a result, the slope of the line represents mBFR value. Case study of prevention for support of designing and operation of RO plants. Case 1. Predicting timing of chemical cleaning. mBFR is useful for roughly predicting the frequency of chemical cleaning. Based on Toray's experience, it is recommended to maintain mBFR below 10, ideally below 5 to minimize chemical cleaning frequency and prolong the lifespan of RO elements. Utilizing mBFR, plant operation can be proactively managed and optimized. Case 2. Impact of chlorination, dechlorination. In the early stages of SWRO, continuous chlorination of RO intake seawater was commonly used to prevent marine organisms' growth in RO plant system. Though empirically known that such operation promotes RO biofouling, the hypothesis has not been scientifically confirmed. Comparison test with and without chemical was conducted, operating two series of UF and RO systems at the same location, using the same system, during the same period. The impact of the RO feed water quality was evaluated using mBFR. Case 2, result. During test period, RO feed water was stable, however differential pressure with continuous chemical was increased, which will be the trigger of RO biofouling. This is the first results in the world that demonstrate the adverse effects of chlorine and SBS addition. mBFR can predict biofouling potential more than 2 months before biofouling occurred. While SDI was simultaneously measured, SDI was not useful at all for evaluating biofouling risk. mBFR can explain the occurrence of biofouling. Case 3. mBFR monitoring at various locations in RO plant. Using mBFR to monitor the biofouling potential at each location of a RO plant, evaluations were conducted for over 10 months at 4 points. Number 1 is intake seawater, number 2 is seawater supplied to pretreatment, number 3 is RO feed seawater, and number 4 is RO concentrate. pH shock was applied for sterilization purposes. Case 3, result. During the test period, the biofouling potential of the raw seawater varied seasonally. However, operating without continuous chlorine or SBS addition allows the RO feed water to maintain low biofouling potential even during periods of high water temperature. On the other hand, pH shock was applied for sterilization purposes, and the RO concentrate remained close to zero, which indicated biofouling was effectively avoided. By monitoring mBFR during RO operation in this manner, the plant can be operated with confidence. Case study of troubleshooting for diagnosis and plant improvement. Case 4. Evaluating biofouling potential by water mixing. This study aimed to reduce the salinity of seawater by mixing it with treated wastewater, thereby making the RO operation of the mixed water more energy efficient. mBFR was measured at 3 points. Number 1 is UF treated seawater, number 2 is sewage RO concentrate, and number 3 is mixed water. Case 4, result. mBFR values of the mixed water, which combined UF treated seawater and treated wastewater, were significantly higher than the average of the two. Consequently, due to heavy biofouling, frequent cleaning was required for this RO system. Such water quality predictions for mixed water are difficult to foresee through the common water quality analysis, but ｍBFR can clearly highlight this issue. By measuring mBFR at various points, biofouling risks can be visualized, supporting the design of optimal processes. Case 5. Optimization of sulfuric acid dosing. STP effluent is expected to have high biofouling potential for RO treatment. Sterilizing with pH shock by adding sulfuric acid was considered, but the appropriate conditions were unknown. Investigations into the relationship between sterilization conditions and mBFR revealed that without pH shock, the mBFR values were high, but sterilizing once every 3 days was sufficient. Case 5, Result. During test period, RO feed pressure remained constant under mBFR recommended sulfuric acid dosing condition, once every 3 days. When shock dosing stopped, RO feed pressure increased, which indicated mBFR was effective for determining sterilization conditions. Case 6. Comparison of mBFR and other indicators. Comparison test between bacterial growth potential, BGP and mBFR was conducted using different types of antiscalant. Case 6, Result. BGP test resulted that both antiscalants seemed to increase biofouling potential. However, mBFR showed the difference of the impact of these antiscalant. Case 6, Conclusion. At actual SWRO plant, differential pressure with AS1 was stable. On the other hand, differential pressure with AS2 was increased. Frequent RO cleaning was required more than once per month. When it comes to feed water quality, SDI was the opposite to the actual plant situation, and BGP could not explain the difference of plant operating conditions. Among these, only mBFR was reliable for explaining and predicting the RO operation condition. mBFR is a reliable indicator that enables to utilize both biofouling prevention and biofouling troubleshooting. Our professional technical experts have always helped solve your needs. With this, we have finished introduction of mBFR case study. Thank you very much for your attention. If you have any questions, please don't hesitate to contact us.